Okay, Alexander, the floor is yours. Enjoy.
All right. Let's see if everyone's back from the break. So you can see my screen, right? So the sharing works.
Yes, everything works.
So hello, everyone. My name is Alexander Egurnov. I'm a senior software engineer at PubNative in Berlin. And today I want to talk to you about testing, and in particular, my favorite testing framework and assertion library, Ginkgo and Gomega. Right. So as a short warm-up, let's see who of you guys writes tests. So you can use chat if anyone is already here, if anyone is alive, just send a +1 if you write tests regularly as a part of your job. So I'll post for myself as well. So I see people are using that already. Glad to see it, Jakub. So for those of you who don't, you probably should. And I want to convince you that it's not as hard as it seems. And basically, good library can take care of most of your needs in this case. So for that, I first will present you Gomega, which is a matcher library and doesn't actually need anything except for Go's own testing framework. So let's see what it can do. Right. So as I said, you can use Gomega completely standalone. You don't need to bring Ginkgo for that. And you can just plug it into your normal Go test very easily and use full power of matching, right? And these matches are quite powerful, so they can allow you to write pretty naturally reading sentences to check your conditions, like I do here, right? So to see a bit more examples, let's change to another file. And navigate through different syntax structures. So first of all, you can notice that when you import Gomega, you can have two different syntaxes, the one which uses expect and the one which uses omega sign. So you can use whatever you want. They read a bit differently, but they're essentially the same. So what you can do, same as with many libraries, you can provide annotations which will tell you which test failed or provide some additional information. In case of Gomega, you can even make them depend on some outside parameters, so you can pass a function. So error handling is built in. So you can check errors, and if you have a function which returns an error apart from its main return type, you can just pass it to Gomega, and this will be all right. So Gomega will check on your error for you. You can also use a bit more naturally reading syntax like have occurred and succeeded to make your tests look human readable. Oh. And the most powerful feature in this section is probably matching on errors. So if you have an error which can be different each time, you can either match on a concrete error, a string representation, or even any string matching matchers which are available as part of Gomega can also go there. So this is where it gets really powerful. Also, if your tests panic or if your code panics, right, you can also catch that. So shouldn't normally panic, but you want to leave this opportunity for yourself. Let's see about equivalence, right? Because you mostly check that things are similar in some way, right? So Gomega ships with an equal matcher, which is very powerful. So it uses reflect deep equal. It may lead to some unexpected results, which we'll discuss later, but it allows you to do complex matching like this one here. So matching a map of strings to int and arrays, even custom structures. So as I said, deep equal will make sure that every field is equal. Apart from that, there are different matches which take different type relations into account. For example, be equivalent to. And in this command here, you can see that there's a type conversion involved, so which might lead to some unexpected results. So you shouldn't normally use that with numbers, but for everything else, it's very convenient. I will send you the link so you can navigate these examples yourself. And actually, I would actually recommend you to go to the docs to read all the tiny details about equal, be equivalent to, and be identical to, as seen here. And yeah, I would say 90% of the time you would use equal, but having these two may be useful if you have a complex type hierarchies. Now, if you're dealing with pointers, you can find be identical to quite useful because it actually checks that the pointer is the same and not just that the structures are similar. So now, as I mentioned before, comparing numbers can get tricky. So what you may want to do is use be numerically. And it comes with additional powers too. So you can compare, apart from normal operators, equal, not equal, greater, equal, less or equal. You can compare with some precision, right? So you can say about the same, right? And you can set a threshold. And my favorite part is that you can actually do the same for dates, right? So something which usually comes with a lot of headache converting date type to int64 and back. So this is like painless and very naturally looking. There are also type-specific matchers, like checking for nil, checking for 0, checking true and false for booleans. So makes for really naturally looking sentences. String matching is quite powerful. So you have your usual prefix, suffix, substring, also regexp. And probably my favorite part of all the string-based matchers in Gomega is you can provide a JSON or a string representing some object in JSON and compare it to another string. And Gomega will actually make sure that these objects, they represent the same entity. See here, they're in different order, but they have the same values. So without actually reading that, you wouldn't be able to do that. So it's all hidden in here. So very powerful matcher. Also, Ginkgo simplifies working with channels quite a bit. So as you see, all the channel reading and writing operations can be hidden with matchers, be sent, receive, be closed. So working with channels becomes quite comfortable, but that's not the best part. So I will show how you can work with channels asynchronously in one of the next sections. Before we do that, let's see what we have for collections. Also, everything you may expect and which is missing from smaller assertions library. So you can check something if something is empty, if something has lengths, contains a certain element, or if some value is an element of a collection. You can check that the collection consists of certain element in no particular order. So here I've changed the order a bit. But also you can combine matchers, and this is one of powerful features also discussed a bit later. But you can basically put limitations on each element of collection, and Ginkgo will go through collection and find element with matches and make sure that all of these constraints are satisfied. So you see here, I'm actually just checking that there's an element with AB, suffix AB, an element with a prefix AB and suffix EF. So like very high level limitation set forward here. Let's see with maps, also the usual suspects, checking for key with value, and also consists of applies here. So you can match against the values in a map. So as I promised, asynchronous assertions actually can make your life a lot easier. So instead of running in a loop and checking if something has happened or consistently doesn't happen, you can have eventually and consistently, right? So here I have some artificially slow process, which returns after some time, right? And here it probably reads a bit better. I can set limitations on how long this thing will run and how often I want to check, right? So essentially a loop hidden, but doesn't make me write this loop and looks really nice. And say for consistently, in this case, you are checking that some process doesn't change, doesn't change its state. Where it gets powerful, and as I promised again, you can use channels with eventually and consistently, and Gomega will check the channel and wait for it to receive something or to be able to send. So this is a very powerful feature which makes testing asynchronous code a lot easier. So let's see some of the more advanced features. So as I said before, you can combine matchers, right? Well, you can use your normal Boolean combination of and or, also called satisfy all and satisfy any. You can negate the matcher, so this allows you to implement any kind of Boolean logic, basically. But apart from that, what you can do is you can transform the value you are testing. So if something returns you a complex value and you just want to check a part of it, you can transform the value before running your matcher. So doesn't look very useful from the first side, but let's see what you can do with it if you take it a bit further. So you can actually provide a function which you use multiple times. And you can even redefine this with transform as a custom matcher of your own. So here I create with name as a Gomega matcher, and this is a really simple interface. It's just 3 methods, and you don't even need to implement them because you usually can transform matchers from other matchers. And a lot of matchers, they take matchers as arguments. So what I'm doing here is I'm defining a matcher with name, which transforms the object it receives, gets the name, and checks that it's equal to some name passed to this matcher. So let's see how you can use it. So this thing here does the same thing we've seen before in with transform, or even with this get name, but now it's a one-liner, which reads very, very naturally. So if you need to do some checks a lot of time in your code, this really simplifies it. And this makes for more maintainable, easily readable code. Here you can see one of more practical examples where you can actually define your own bin range matcher. And as far as I know, it's not part of standard Ginkgo Gomega matchers. So simply doing that, you can provide this matcher for your own use. Nice. So this was just a Gomega. What about Ginkgo? So let's see. Now, Ginkgo is the world testing framework, right? So, and this plugs into standard Go testing. So it's compatible. And actually, when you run Go test, all the Ginkgo tests will run and vice versa. So you don't need to rewrite your full CI/CD pipeline for that. And there's very little dependencies between Ginkgo and Gomega. This here is actually the only line where they interact in any fashion. You just tell Ginkgo how to fail tests or how to know the tests are failing, because fail, I think it's provided by Gomega. And this is the point where it connects to standard testing, right? Because you see this test suite is actually a normal Go test. So this is where Ginkgo connects to Go testing framework. Right? Now let's see about Ginkgo specific things. So Ginkgo comes with a behavioral driven testing style DSL. So you see the test tree is built. So this piece here, you kind of built it without assigning it to anything. And you see there's a lot of closures everywhere. So all these functions are stored for later use. So Ginkgo allows you to structure your tests. So you can use describe, you can use context, which is the same as describe. You can use when, same as the above two. So the actual tests are introduced as it and specify. And then your string, your test name, the test name you provide usually picks this it or specify depending on your style, if you're using any strict behavioral-driven testing framework, or if you just want them to read naturally. So one of my favorite features is that you can actually exclude tests by just prepending X to it, right? In the same way, if I want to focus on just one test and I don't want to provide a focus parameter on the command line all the time, I can just prepend F, and I will just running these tests. This is also very comfortable to run. So what else can I do? I can obviously fail a test if I want to, although with a proper matcher library, you rarely need to resort to these directly. So if you're a fan of long tests with complex setup, which happens sometimes, you can use by to just separate the steps. And if you fail, you can see them printed in order, so you get better idea of where your tests failed. Also, as a lot of more complex testing frameworks, Ginkgo comes with a test setup system implemented as before each, just before each, just after each, and after each. So it allows you to create some objects in before each and run all the before each down the test tree before you start running just before each. So you can create the objects in before each, and you can apply the changes, commit them to the database, so do some actual preparation work in just before each, while having a chance to override objects in a later before each. So to demonstrate this, I will actually run the tests here. So I focus and I go to terminal, and yeah, I will just run Ginkgo, not to run the other files. I'll just go to Ginkgo folder, run it, and let's see what it prints. I didn't print anything interesting. Oh yeah, I need to make it verbose. Yes, so you see what happens here is that I have several tests. So, and all before each run first, then just before each runs, and allows to override the variable I had in my test, run the test, and then in reverse order, run the tear down and whatever you may want to run in just after each or after each. And also there is a similar functions you can run before and after the whole suite, right? So you see here I have two tests. So before suite runs, before all of them, then this is the outer test, and you see it's only affected by its own before and after setup, and the value is original, so not overridden. So for test number 2, I override it and add some more setup. Right, so we are 20 minutes in, so I will be getting close to an end pretty soon. So let's see what else Ginkgo allows you to use. it has its own asynchronous testing routines, not in the same way as Gomega. So it's not the thing which you use for channels. So, but rather, if you have a test which launches Go routines, like this one here. So you might know that when you launch a Go routine, Go proceeds immediately. So this test will actually finish before this Go routine gets a chance to do its work, right? So here I have sleep as a way to offset this. So what actually happens here if I run this test? Actually, let's run this test. So what happens here is it reports that it failed in a function that doesn't do anything bad, which may be misleading, because this test finished way before this Go routine called fail. So how do I fix that? And this is where asynchronous syntax for Ginkgo comes in. So I pass a channel done, and the test is only done when this channel is closed, right? So when it's done properly, you can see that now it will point to the right test failing. So now it fails where it should fail. So, and this is something which cost me more than a couple hours of my life. So now you know it. So hopefully I've saved you some time. Okay, and the best thing again about having this dynamically built testing tree is that you can actually, well, build it dynamically. So you can actually create tests in a loop, build this tree, and then have it run at some point in time. So still, this is a closure. So keep an eye on loop variables, but otherwise very flexible. But that's not all. So you can also have measurements, and they're a bit more powerful than normal Go testing benchmarks. You may know. This allows you to get a bit more statistics and also track some more variables. So let's see something interesting. So yeah, this is a measurement. So this takes a benchmarker object, and let's see where it's used. I can record optional values. So in this example, I'm trying to just put some values through a worker pool. So here I have only one. In the next measurement, I have a couple. And I'm counting how many objects each worker processed. So if I run this now, just to demonstrate you the colorful output, and you can also make it JSON or whatever you want for analysis later. Here. So it provides a bit more statistics, slowest, fastest average with some credibility interval, and also for the counts you provide. So like a lightweight statistics tool for you to use. And you see here, it's quite believable that two Go routines didn't actually distribute work exactly evenly. And for a single Go routine, it just got all the work items to itself. And one of the last features I want to tell you about is testing for flaky tests, because sometimes tests fail randomly, right? So what you can do with that, you just run tests until they fail. So luckily with Ginkgo, you can do that. You can run until it fails and wait for the first time something fails, or you can give a certain number of attempts to rerun tests. So here you see I will randomly generate a number and wait for it to be exactly what I want. So let's see how long it takes me to reach this number. Yeah, this time it took more than 100 attempts. So normally you would expect this number to be lower, but well, randomness and randomness. See, now it's 52. So this is a really hard test to catch. So chance of failing is 1%, right? So normally this takes a lot of headache. But thanks to Ginkgo, made it a lot easier. Right, and as I said, all these tests can be run from within normal Go testing framework. So you can do Go test here, actually. No, what was that? And it should pick up Ginkgo test as well as Go tests. I had an example of Gomega, so you see it run both tests. Now, one of the features I probably don't have time to showcase anymore is that you can make Ginkgo watch your tests and report every time you save. And you can even use a terminal notifier to make a small notification window pop up. Unfortunately, it doesn't show in Zoom, so I won't be showcasing that now. But if you like writing tests iteratively, making them red and green and red again, this might be a really interesting feature for you. And in Ginkgo, it's called watch with minus notify. So that I'll just paste it here so that you see. So this is a command you might want to check out. And this brings it to an end. So this is all the features I wanted to tell you about today. Drawing to an end, I want to stress that you shouldn't use Ginkgo for every test you write. It's arguably a big testing framework, so you might make do with standard Go testing. But when your tests get big and need complex setup, Ginkgo can simplify them a lot. So in my company, we rewrote our E2E testing using Ginkgo and Gomega, and it was a lot easier to develop after that. And thank you for your attention, and I will be taking questions now, if you have any questions.
Thank you, Alexander. Guys, do you have any questions?
Hey, it's not really a question, but there is also a really nice feature for the table-driven testing, right? I don't know if you have seen this, but you can do describe table and do entry, entry, entry. So it's really nice. But okay, also, what are the drawbacks that you see when using this? Because my experience is that one thing that really bothers me is that I cannot run individual tests in Golang, right? I cannot run the single it. I need to run the whole suite. And the second thing is that sometimes I feel like I write in JavaScript because of the lack of generics, right? So I could write something like expect 5 to have elements of 2, 3, right? I can mix match the matcher from collections and numbers and everything. So what is your experience?
So yeah, I agree that there's a lot of interfaces involved, which makes it on one hand powerful. So as I said, you can combine matchers, but if you don't use it, you may not even know you can do that. So there's a lot of introspection under the hood, which probably makes them a bit slower, but you wouldn't notice the difference. Probably the biggest drawback is that if you don't pay attention to how you structure your tests, these test structure can get monstrous, right? And it will be hard to track all the before and after conditions, right? So, but this is not a problem of frameworks. This is a problem of how you use it, right? So in our team, we just set a limitation of how deep you want to go and how far you want to store the setup from the actual test. So this probably is the biggest possible drawback you can run into. Regarding the table testing, yes, there is actually, I think, more plugins. So there are more extensions to Ginkgo and Gomega you may use. And I think you can even write your own. So that's definitely a possibility. Am I missing something of your questions? I think I started answering them out of order.
No, I think that's it. So thanks.
Yeah, thank you. Anyone else? I see a question in the chat from Pedro. Can you match a JSON schema, and how does it work with mocking libraries? Well, about JSON schema, so I guess if you want to check that certain string can be parsed into a JSON object, you would normally just try parsing and check for errors. So this is your matching against the schema, so to say. If you have an object and you want to check that it looks the same, for example, you want to check that your API outputs an object which looks a certain way, I would use this match JSON and match two strings essentially, and check that they represent the same JSON object. And mocking libraries, it's up to you. So you can use your own mocking library. I don't know if there's a preferred mocking library, not last time I checked. So you can use whatever you want. I personally used several different libraries, and most of them do some kind of code generation. So it's whatever you prefer. So it doesn't set a strong limitation on that. And let's see, I think there were no other questions in the chat. Yes. So quickly going back to the presentation. So I encourage you to read the docs. So they have a lot more information than I just presented. Oh yeah, you see that not just testing is available, so streaming and external process management and complex data types management. So there are extensions, so you can make it as powerful as you want it to be. And here is the link to my talk. I will also post it to chat right now, so you can go check it out. Shall I just copy it from here? So feel free to fork it, experiment with it. All the code I've shown is in this repo. So if you need to look up any of the tricks I've shown, if you need to play around with it, feel free. It's for everyone to learn. So that's it. Thank you very much.
Thank you, Alexander. Very good presentation. To be honest, I also learned a few things about Ginkgo and Gomega. I thought I know the library, but today I learned a few new things. Very good presentation.
Surprisingly, they have been updating it for a long time.